Well, hello again, everybody. Thank you all for joining me today. I hope that you all had a great and relaxing holiday weekend. My name is Palan. I'm the product educator here at DMF Lighting. Today, I'm going to be going over our newest webinar presentation for you guys. It's a downlight optics and glare. So we're going to discuss different types of optics that are used within downlighting systems. I'll go a little bit over the role of optics in general and why we use them. Talk a little bit about cutoff angles. They're not directly related to optics, but are pretty important for glare and glare control. I'll then go into some different types of optics that are used in different downlights. Also used more broadly in lighting, but specifically for downlights. And talk about some of their advantages and disadvantages. And then we'll spend a fair amount of time going over the different optics that are used in all of our fixtures here at DMF Lighting. And then at the end, we have some additional resources for you. This is all based around a new technical bulletin that covers this exact topic. So you'll have all of that available to you in a really sort of extended format that you can read through and really dig into some of these different resources. So first of all, to talk about the role of optics in general, as we have moved into, I should preface that the optics and optical control has been around long before we started using LEDs. But with the advent of LEDs, it's changed in how we have to approach and create optical systems for our lighting fixtures. So LEDs on their own cast light in what's sort of really a Lambertian or a diffuse pattern. They don't discriminate in terms of the direction that they do. I have a fixture here without any optic in front of it at all. And you can see as we turn it on, there really is no sort of direction or place that the light won't go. Its only real limit is actually sort of the cutoff of the edge of the fixture that is sitting within. But when it doesn't have anything in front of it, that light doesn't have a lot of means of control. It spreads out in a very broad direction in all sorts of directions. So that's generally not the most advantageous dispersion for when you're using a downlight within a ceiling, especially as our ceiling heights grow in larger spaces or in more modern, taller spaces. Having some optical control is really paramount or necessary to be able to get useful and functional light out of your fixture. So that use of optics is going to help us first and foremost, create a tighter beam spread that gives us more controlled lighting that we can spread throughout our space and have functional light in our applications. Another sort of added benefit that you get from that, though, is that they help to reduce unwanted or stray light that isn't really being useful for lighting, again, the room or your work surface or whatever it might be. That unwanted stray light that goes out in all directions ends up causing what's called glare. So I think a lot of us are familiar with glare, but glare is really that disturbing or sort of uncomfortable feeling you get from unwanted stray light in your peripheral vision that's going to be distracting to what you actually want to see. So utilizing optics helps us to also reduce that stray light and that glare. And that glare reduction is really important for all types of fixtures, but especially as we get down to smaller aperture fixtures. So typically around 3 inches and below, when we're going to about 1,000 or 1,250, 1,500 lumens in a small aperture format, reducing that glare as much as possible is really paramount, because we're taking the same number of lumens and squeezing them through a smaller aperture. So you have all that light output is concentrated around a trim or that exit aperture, you get a much brighter source in your field of vision. So, and there are a number of different ways that we'll talk about that engineers and optical designers go about sort of combating this. But again, just to really impress upon you, as the industry moves to small aperture fixtures, glare control has become an increasingly important part of the fixture design, the optical design that we undergo. Real quickly, I'm just going to talk about cutoff angles and how they sort of play into glare as well. I'll put it out there and just note, interestingly, there seems to be a large mix of how people define cutoff angles. There's also the term shielding angle out there, which tends to be the opposite of what I'm showing you here on the screen. but I have seen other places, other manufacturers, other resources define the cutoff angle as the opposite of this as well. So sometimes it really helps to just have to also look into the data and see what they're referencing. But generally, and here at DMF, we refer to cutoff angle as the angle that you see here on the screen. So it's measured from the nadir of the fixture, which is essentially just the perpendicular line going straight to the ground. And then the angle at which you can no longer see the LED and the open source. So typically in our downlights, that tends to be a lens or an optic that sits right behind the trim. And it tends to be that corner of the trim and the optic where those things meet. So that cutoff angle really describes the place at which outside of you cannot anymore see direct view into the brightest part of the fixture, which is either the LED or the optics. So that relationship between the overall optic size, the trim geometry, so the depth, the height, the width, all of that, is going to help define or ultimately does define cutoff angle in our fixtures. So by this definition, the way that we're looking at it here on the screen, if you have a smaller cutoff angle, a more narrow cutoff angle, so 40 rather than 50, that smaller number is going to be a preferable cutoff angle because there are going to be fewer positions where you can see it throughout the room. This higher, or I said better cutoff angle really, really translates into a more comfortable environment because again, as you are in any sort of normal position where your eyesight is cast sort of straight forward or down at your work surfaces, that more tight cutoff angle is going to help again cut off the places where you can really see into the fixture in any sort of normal circumstance. So that's one thing that we do really take into account as we design downlights, is really thinking about the overall depth of the regress of the trim, the overall proportions. This is the other reason why using a pinhole trim as opposed to a standard trim is a lot less glary because you're greatly reducing your cutoff angles by coming in typically about twice as far as you would on a standard recessed downlight trim. So just one thing to think about as we talk about optics and glare and how these things all work together to create a quieter fixture in the ceiling. So with that, I'm going to talk about some different types of optics that are utilized in downlights and some of their different, again, advantages and disadvantages. So reflectors are probably one of the first things that a lot of us know about and are probably one of the most commonly used and have been around for a long time, even going back into incandescent lighting, all of our sort of fluorescent, metal halide, all those types of sources really often utilized a reflector type of optic. Even those sort of PAR lamps that we were used to, that stood for parabolic aluminized reflector. So it's a really widely used type of technology and type of optic in lighting in general and in downlights as well. So reflectors really utilize a very sort of specifically shaped, a specific geometry of a reflective surface that is formed around the light source. So in modern LED lighting systems, the LED tends to sit the back of the reflector here and then shine into, again, the sidewalls of that reflector. Both the shape as well as the form or the texture of that reflector help to define what the overall beam spread is going to be that's coming out of the reflector. So there are different types of reflectors in this category as well. There are totally specular reflectors you can think of like as mirrors or polished metal. There's also reflectors like this that have facets in them that help to sort of direct light in very controlled ways. But reflectors all work on the principle of reflection, and that when a beam of light hits a surface, it bounces back at the opposite and equal angle. So engineers have to work within those sort of constraints, the realities of physics, to make a reflector design and shape that's going to give ultimately the beam spread that we want. Reflectors are great in that they tend to be pretty low glare because of the depth of the fixture itself. So you can see compared to the LED source size here, this depth of the reflector is very deep. So you generally get pretty good cutoff angles with reflectors. They tend to be pretty simple to manufacture, and it's a practice that we've been doing for a long time. But they do take up a lot of space, given that overall depth of the reflector here. They're really more suited for deep format architectural downlights that have a lot of plenum space, are not restricted in many ways. And they tend to then add sort of that visual height to your space as well. One thing also about reflectors in terms of some disadvantages is that generally some light rays still do escape the optical system unaltered. So generally anything that sort of hits out to the side of the reflector is going to bounce off that reflector and be controlled by it. But there's a whole collection of light rays in that middle sort of angle that don't escape, or that do escape the reflector without touching it at all. So that does mean that you do have some light that's sort of uncontrolled or spill light that can cast off into unwanted directions. So overall, they're a really great technology, great piece of optics and great systems. They're very effective. But again, as you have Lambertian sources that really radiate in all directions, they can be somewhat less effective at controlling glare in that way. That's why we saw such great effectiveness with maybe more incandescent sources or sources that took up more space in the reflector, because you could somewhat more easily design around that in terms of how you shape the light. But nonetheless, they're very commonly used. And I should preface all of these, the different ones that we're going to go through today, and say that often and pretty much always, these are typically used in combination with each other. So we'll go through and start to see places where they mix and multiple optical systems or types of optics are used in a single fixture. The next type of optic that I'll talk about is a TIR lens, or really refraction lenses, because that is the sort of more broad and encompassing category of optics that we're talking about. So refraction is another type of, another principle in optics, where when light rays pass through a medium or a different medium, so whether if they're going through air and then into plastic, let's say, or glass, light is going to bend at a predetermined angle. So based on what's something called Snell's law, which determines angles of refraction, light, as it passes through those mediums, changes its direction, and then as it passes out of that surface, it changes direction again. So one of the really, or the most commonly used type of refraction lenses in lighting is something called a TIR lens, or total internal reflection. TIR lenses are great in that they really can come down to some very compact form factors, so they can be very shallow and take up very little space or very little depth in a fixture, something that we all are becoming more and more familiar with as plenum spaces become very restricted. What TIR lenses do as the light rays enter through the back of the optic, they enter through that refractive entry surface. They then bounce around the inside, so they reflect on the inside of the optic to an outer wall. So they'll basically come in through the middle, hit a reflective surface in here, and hit another reflective surface on this outer wall. And then they tend to exit the front of the optic in sort of a collimated fashion, or in other words, a way that they all sort of go in a sort of a singular direction. So they're really great at, again, collecting light rays and condensing them down. Again, that's a big part of optics in LED fixtures, going from a wide 180 degrees into a much more concentrated package. Really helps us to get more usable light out onto the floor. So they're really, again, commonly used in those very, very shallow fixtures, or the places where you need to shave off all possible height of your fixture. They are really sort of very precisely designed around the LED package and the size of the package that you're using. So that relationship between those two is really closely linked. So especially as you see, if you try to get into more narrow beam spreads, the size of the LED package might sort of dictate or limit you in terms of how narrow you're able to get with a TIR lens. I'll talk about some of our fixtures later and some of those cases where we had to work within those constraints because of that. One thing about TIR lenses is that they tend to also introduce some chromatic shifts or fringing, color fringing around the outside of the beam. So that can be a disadvantage. And they typically, not always, but typically need an additional sort of diffusion or smoothing optical element to make them a more sort of complete package or a complete optical system. So really, they're great at concentrating light and making them sort of very, very collimated, but having a smooth beam, a smooth edged beam of light that really sort of nicely fills a space tends to utilize an additional optical element in most cases. So those are TIR lenses and refraction lenses in general, again, really widely used in downlights. And then the next one that we'll talk about is one that's really commonly used in combination. So I mentioned at the end of this, or the end of our TIR lenses, that you almost always need additional diffusing elements. This next category of microstructure optical films tends to be one of those most commonly utilized together. So microstructure optical films are, again, pretty widely used throughout the industry. What they tend to involve are essentially sort of a printing or a film process that goes onto some sort of substrate. So either acrylic or glass are the two most commonly used ones. At a very, very tiny sort of microscopic level, what happens is that film that gets deposited has very precise and repetitive patterns that go into that film. So they can either be sort of prismatic arrays, lenticular profiles, which are those sort of pieces of artwork that you can look at where as your viewing angle changes, so does the image behind it. So they have these sort of multi-arrayed lenses. Moth eye patterns, which have a sort of very narrow band of view that help to sort of direct light in lots of ways. So there's all these different typically one variation, but all these arrays of tiny, tiny little profiles that help to concentrate and shape light in very directed ways. So they're really great at diffusing light rays and essentially creating a pretty well-controlled beam spread. They do this by scattering the light in the sort of directed manners. And because the light that's coming through that lens is coming at it in different angles, it can then spread it out into sort of appropriate beam spreads. Microstructure films are great in that they're very low profile and compact. Obviously, this is just a couple millimeters. It really the film itself is almost nothing. It's really the substrate that you're printing onto that takes up any amount of space. So they're excellent in that they can be sort of layered on top of other optical systems, or you'll see them very often sort of in landscape lighting as well, where we stack maybe a couple optics inside of a compact fixture, or in our case with downlights, where we maybe have a TIR lens and then an optical film or a micro diffusion film over that. Really great at sort of helping us get wider beam spreads. They do tend to introduce some randomness into the beam because of that, because of the two different optics at play here. So we have light coming in at different angles, and then this repeating pattern that's going to, again, introduce some randomness into the beam spread. So they do, in a way, increase glare in some cases. They don't fully control light that's being spilled out into the trim. So it's sort of this delicate balance between the two to get ultimately what is a low glare fixture at the end of the day. The next topic to just sort of bring up is something called crossbeam optics. Now, this is not necessarily a type of optic, so I want to impress that upon you first. The three that we've just discussed of reflectors, refraction lenses, and films, those are physical media that create optical control. A crossbeam optic can be achieved really through really primarily the first two, either reflectors or TIR lenses. But it really describes a focusing technique in which the light beams of a fixture cross at a secondary focal point. So some of you may have seen this animation from some of our X series videos. But light that comes out of the fixture, rather than coming out in a traditional fan shape or V shape out of that optic, crossbeam optics cross the light into, again, that secondary focal point where they meet, typically as designed in a downlight, at the ceiling plane. So these are great because they really reduce excess spill light onto the cone or the trim of your fixture and really reduce glare in that way. They also tend to be more efficient in general sort of side by side with a standard trim, which is like a standard optic and a crossbeam optic. The crossbeam optics tend to be more efficient. So that's a really great added benefit in that way. And because of that, because of the crossbeam nature of it, where we're making that X shape, they also perform very well with pinhole trims. So pinhole trims, again, bringing us down to that smaller aperture size, create much more aggressive or better cutoff angles, quieter ceilings. And if you're able to squeeze the same amount of light through that center point, you get much more efficient optical systems. So whereas a standard optic might have 60 or so % light loss, with a pinhole trim, you're looking at maybe 20 or 30% when utilizing a crossbeam optic in the same fashion. So once again, this is a sort of a focusing technique and something that can be employed in different types of optical systems, but really effective for creating low glare downlights. That brings me to a last sort of group of optics, which are something that are classified as non-scattering optics, or also referred to as imaging optics. So these might be familiar to you if anybody does photography. These are all the types of lenses that make up a camera lens. They also make up certain types of spotlights. So if you have like a framing projector in like a museum application, or also image projectors where you're able to project gobos or images out of a light fixture, these all are going to use non-scattering optics. So these come in the form of what we think of as traditional lenses. So either convex, concave, different types and shapes. But the biggest property here is that non-scattering optics do not introduce randomness into the beam spread. So as light rays come through them, they come out in a coherent manner. In other words, they're going to preserve the overall sort of spatial relationship of those light rays, so that what comes out the other end is going to look the same as it did from the source. So that's why they're often referred to as imaging optics, and why they're used for imaging applications, because they, again, preserve that picture and the overall arrangement of those light rays. The biggest thing about non-scattering optics is that they are completely unforgiving to any imperfections in the source image. So LEDs and manufacturing light sources in general is not a perfect science, as we all know. We deal with binning, we have slight imperfections, differences in light sources. So any piece of dust, anything that gathers within the light fixture can start to be revealed by a non-scattering optic, because its main job is to preserve all of those light rays and give you a very faithful image. So when it comes to being used in downlights, these tend to be not very well utilized in a lot of types of fixtures, again, except for some of our more specific applications, like I said, in terms of framing projectors or image projectors and things like that. So with that, I'm going to go into now sort of our product portion of the presentation and talk about the different types of optics that we utilize here at DMF. So the first to start off with will be our M series family of downlights. This is our 4-inch downlight family. I'm going to speak to first the 750 to 2000 lumen set of fixtures. So the 750 to 1500 are IC rated. Our 2000 lumen pushes into the non-IC rated section, but they all utilize the same set of optics on the inside. So what we have here is on the inside is a proprietary TIR optic that we've designed for this fixture. Again, this is a very compact profile, and the LED sits only about halfway into the depth of this assembly, because the driver takes up the other half. So we have a very, very compact TIR optic that concentrates the light beam down to about 15 degrees. So when you turn that on, you get a very nice, or rather I said a very tight sort of pool of light. Again, it's sort of collimating most of those light rays and bringing it down to this beam here. As you can see, however, this beam does not have a lot of uniformity to it. We have sort of rings and color fringing that come into there. So we have instead, or in addition, are a set of microstructure films that go over the top of that. So these acrylic lenses go into the top and give you the final beam spread of the fixture. So you see we went from a 15 degree to now our wide flood, which is about 60 degrees. So we spread the light out much more, have much more evenness, and a nice smooth beam spread coming out the front of the fixture. So that is what we utilize here with our 4-inch fixtures. It's not a crossbeam optic because in a 4-inch aperture, crossbeam optics and getting that sort of reduced glare on the trim is a lot less paramount. That has more surface area to spread out, and those sort of excess light rays don't tend to have nearly as much effect as they do in smaller aperture fixtures. I should note, so this combination of the TIR optic and microstructure films, this is for our narrow spot, spot, flood, and wide flood, as well as our linear spread options. So that range goes from about 15 up to, again, like 60 degrees, and then our linear spread is about a 50 by 30. So those all utilize that same combination of those two elements. The other option that we do have here is what's called the GA, or the general ambient. This falls into a category of really just a Lambertian reflector and diffuser in the front. So this reflector is really just sort of a simple white acrylic that sort of spreads light in a very Lambertian sense, or in other words, a very soft diffuse sense. And then we do have, again, just a diffusing film over the front of that. So these GA modules, or GA optics, I should say, were one of the first or was the only option when we first introduced the family. So these create a very, very wide beam spread that goes to about 90 or 90 plus degrees. Tends to be a little bit more dependent on the trim that you're using. So like our standard recessed trim is about 90 degrees, but if you go to like a flush mount trim, which we have some retrofit options for, that brings it up to even past 100 or so degrees. Again, this is really a Lambertian beam spread in this GA optic where you're letting the light bounce around sort of at will. So they are useful in some senses if you have very shallow ceilings or are limited in your downlight layout, where you can't quite get as many fixtures as you want if you have, say, a wide flood or a spot optic. So we do have that option available as well, and it's definitely useful in a lot of different instances. The next, all right, there we go. Next set of fixtures in the family is going to be the IC rated adjustable. So this is pretty similar, although we moved down to a pretty small size here. So we have a smaller lens in the front, and this is simply just a TIR optic. So I mentioned often we use additional films or things like that. In this case, this is one instance where we have just a TIR optic. So it's a similar sort of structure where we have light rays bouncing around inside, but we have different elements of these that go between our narrow spot, spot, and flood, and linear spread. So these change the actual beam spread of the fixture itself, and then allow you to get your ultimate beam spread size. This ultimately does give you a very nice soft beam spread. So that single TIR lens is designed in a way to scatter light and give you a nice soft edge beam spread, no matter the beam spread that you're using out of these different options. So that's one nice thing. It's a very sort of simple system with only one element on the inside. I should also note, like you can see on the screen here, this family does have an option for a hex cell louver. So we're talking primarily about optics here, but in the name of glare control, hex cell louvers are a great way to add that in. So our adjustable fixtures in this family do have that option as well. The next set of fixtures, so this is still in our M series family, our 4-inch downlights. This moves into our non-IC high lumen downlights. So this is 2500, 3000, and 3500 lumens. You see that the fixtures get considerably larger. The module itself is pretty big, and this is one instance where we do have a removed supplemental driver. But the real approach here is a reflector and diffusion lens combination here. So one primary thing that happens, or one thing that shifted us to this approach, is that these high lumen downlights of 2500 plus lumens get significantly hotter at the LED. They create more heat. They also rely on a larger LES, or light emitting surface. So you can see on the inside, it's a pretty sizable COB chip because we're moving up to that high lumen output. So overall, to get to a manageable beam spread, we need a deeper depth to get that geometry and the trim and the reflector to be able to get to between a spot, flood, or wide flood beam spread. So that's the combination that we have here. We have a reflector and then again a microstructure film that goes over the top of that. So these work really well to give you a very nice, reliable beam spread out of your fixture. They also have the advantage again in that because they are so deep into the LED, they really on their own reduce glare quite a bit. For a 35, this is a 3500 lumen downlight, the amount of glare that you get out of sort of the front of the film is greatly reduced because that that very bright 3500 lumen source is buried pretty deep within that reflector and really effectively controlling the spread of light out of the front of the fixture. The next group of fixtures is going to be a very similar approach here. So this is the M series non-IC adjustable fixture. So you'll see it looks nearly identical. We have a different heatsink format that allows us to get our 40 degrees of tilt. But the optics on the inside, while more shallow, are the same reflector and diffuser combination. So in this case, we actually have a clear lens over the front. There's no diffuser involved. Some of them do have a slight level of diffusion, but really we're relying on reflectors in this case as well to do all of our beam shaping in this instance. We do again on this adjustable in this family have hex cell options available. You'll find they come as a full package, so you specify it with the optic. It's sort of built as one unit, so you get the optic, a holder, and then there's actually a glass diffusion lens in the front of this one because that hex cell can absorb a fair amount of heat, especially in these 3500 lumen packages. So that is our set of non-IC adjustable fixtures. Again, available in the narrow spot, spot, and flood options. The next family, so this is our X series family of 3-inch downlights. I'll take a quick pause and just note a lot of you, if you've been with us, maybe have been used to hearing the X series as a 2-inch family. It's not updated everywhere, but we are starting to really transition and update that to more accurately reflect the true sizing of the trim. So you'll see names and nomenclatures shift a little bit to 3-inch. The part numbers are going to remain the same, so please don't be alarmed about that. But it is truly sort of a 3-inch downlight family. That said, the X series utilizes, again, a TIR optic, but we are utilizing, in this case, a crossbeam optic approach. So the X series going down to, again, like I said, a 3-inch aperture, really starts to get into that small aperture category of fixtures. So what we have here are two pieces again. So we have a TIR optic and a diffusing lens. So the diffusing lens comes out of the front of the fixture. However, in this case, this diffusing lens is the same for all of our fixtures. So we have a couple options that I'll talk about in a second. But we have one set of diffusing lenses, and then this optic on the inside, the TIR optic, is what's doing our actual beam spread control. So if you're going to change between any of those options there from narrow spot up to wide flood, you take this piece out and then put a new one in, and then you get your updated beam spread. But once again, this is a crossbeam optic system, so it gives you that crossbeam focus where your light rays are meeting all at the center and not reflecting nearly as much on the trim or getting cut off by your pinhole trims. I should note on the bottom of the screen here, we have a UN or an ultra narrow option as well. This is one instance where in order to get, down to a really tight beam spread, this is a 10-degree beam spread. The narrow spot is just about 20 degrees. So to get that much smaller, it's not physically possible to do with an optic alone and maintaining the same LED chip size. So this particular option is paired specifically with a 500 lumen output and a 10-degree beam spread. So to get that ultra narrow beam spread, we had to go to a physically smaller chip to be able to get down to that small beam spread, all while maintaining that form factor. Typically in optics, as you go to a tighter beam spread, you generally need a longer and larger optic to do so. So that is where that comes into play, and how we are able to get down to that single 10-degree option. I've been showing you so far the downlights in the family. I should note that the adjustables are the exact same approach. It's actually the exact same optic on the inside. This TIR lens is exactly the same between the two sets. We just have a different holder that goes on the front. So you can pop that on and off rather than sort of pop it out with those two tabs. But same overall approach. This is also one instance where, or one family, where the beam spread out of the TIR lens is really quite well smooth and controlled. So we're really utilizing these diffusion lenses just for sort of final beam shaping, and really also to get just a last little bit of lensing and protection over it. This is without any diffusion lens at all, and this is with our diffusion lens added back on. So you see the overall beam spread is pretty much the same. We're just kind of adding a soft level of diffusion onto the front of it. You can see on the screen here, these are the different options that we do have. So you have new sets of lenses to go on both the downlight and adjustable. We have a clear option, which is entirely clear and doesn't have any diffusion on it at all. And then we do also have a heavy diffusion option. So that goes in and adds sort of one last little oomph of beam spread. So if you're in an instance where you need more beam spread out of your fixtures, or you just want to soften the beam a little bit more, on the X series, you do have that heavy diffusion option. You'll just find it under the optical accessories, not in the standard product builder, but the optical accessories. And you can get those lenses added on to your order. The other thing, we do have hex louvers available for the family. So both for the downlight and adjustable, which is really nice. You can add that on as an accessory and get hexel louvers to, again, really increase your glare control and overall quiet your ceiling. Real quick, I'm going to talk to the H series and the C series together because they're really both largely the same in their approaches. These are very much just like our general ambient on the M series, where we have essentially a mixing chamber. So this is a C series trim. So the trim itself has a reflector and then a diffusion lens over the front. H series as well has the same sort of approach. I have one taken apart here. I should note these are not intended to come apart. So people try often knowing our products, but these are not intended to come apart, but just for demonstration purposes. You can see we have, again, a diffusion lens and reflector that sit together nicely and go over the LED to give you, again, about a 90+ degree beam spread in this instance. Should also note, again, just sort of like with our M series, the trim, particularly with the H series, we have interchangeable trims. So like our flush mount trim does give you an even wider beam spread than, say, sort of our standard regress trim. So it's something to keep in mind as well. Next, I'll talk quickly to our S series. So this is our surface mounted downlight. It's really going to be the most affordable product that we offer, and really the most compact. It fits really just into any junction box with the driver in the back. Then the whole fixture sits below the ceiling. So this fixture utilizes an array of about 150 lower powered LEDs that then have a diffusion lens over the front of that. So similar to some of our other fixtures here, this diffusion lens is just going to soften the beam spread. And this fixture in this case has about 112 degree beam spread. So very wide angle, great. Again, if you have very shallow ceilings or are limited in terms of the number of fixtures or your layout, because it's going to help really fill the space very broadly and diffusely with light. And they have that advantage that they're very low profile and very affordable to sort of manufacture and to purchase. That is going to bring me really to our last fixture to talk about. I sort of intentionally put this last because our True One downlight is really in more of a pre-production phase at the moment. So we're not shipping this till closer to the end of the year, maybe beginning of 2027. However, it has a pretty cool optical design that I did want to talk about with you all. Again, like I said, moving to small aperture fixtures in this True One downlight is a very small aperture. It's truly a 1-inch aperture. Controlling glare is really paramount because it can create very disturbing and uncomfortable experiences to have 1,000 or so lumens crammed into a 1-inch aperture. So this is the actual one of our modules themselves. This is the adjustable module. It has sort of an angle to allow it to tilt the proper way. But the optical design that was gone with here was pretty unique. So we have a patent pending 3-stage optical stack design that really gives us a very controlled beam spread and a very low glare solution. So it has three non-scattering optical elements. So I actually have, again, a disassembled one here. This is not to be done normally, but we have sort of this primary lens that's just behind the LED, which is a glass lens, and then 2 additional lenses that sort of sit in opposition to each other. So these are made of silicone, which is a great material for optics in that it's non-yellowing and UV resistant and all of those things. But those 2 lenses work together to really sort of focus the light and then ultimately create a cross-beam focus or a crossover focus. So that, I didn't say really specifically the text here, but this is a cross-beam focus. The main advantage here is that going into using what are sort of non-scattering optical elements is you get a true crossbeam where those light rays all really intersect at one very confined and tight point out of the exit aperture. So again, going down to a 1-inch fixture really limits and it makes it more paramount that that light spill is not going to hit the trim and any sort of unwanted directions. So we're able to do that by utilizing really non-scattering optical elements to control the light in a very precise manner. Ultimately, again, like I said, those non-scattering or imaging elements are not very forgiving to any imperfections. They also create, without any diffusion, create a very hard edge beam of light, which is generally not wanted unless you're in the theater. So what we do have here as well is one very controlled layer of micro diffusion that goes over the final element of the optical stack. So that does the final sort of beam shaping and softening to give you a nice controlled soft beam of light with a very low glare solution. So that's the true one optical stack in the design here. Again, still in our pre-production phases and coming out later this year, but a really sort of unique approach to doing optics in a 1-inch form factor that give a very low glare solution overall. So that is all the stuff I have to go over with you for all of our DMF products. Again, I'm just going to point you all to our technical bulletin. I just checked before this, and I'm sorry this is not updated. It does not seem to be live on our website, but we're working on getting that fixed as soon as we can. But we'll include this in our follow-up email to you all. This technical bulletin has all of the information we've gone over today in a pretty in-depth manner, so you can read through all about 7 pages or so and get a great feel for all the different things that go into these types of optics. So with that, I want to say thank you all for joining me today. I know this is a longer format presentation. There's a lot of information here, but I hope that was really helpful and useful. Once again, hope you all had a great holiday weekend, and I'll see you guys in 2 weeks. We'll be going over some new retrofit options that we have here at DMF as well. So please join for that if you can. Thank you.